precious. I just came here to defend.
All right, I'll get started now. Hopefully I'm speaking clear enough and loud enough. Can everyone hear me in the back? All right, cool. Well, thanks for having me here, or having us here. My name is Adam Birkhoff. I'm the chief engineer on the forward deployed product development team at Palantir. And today I'm going to be talking to you about a product that we built and kind of the process of how we built it. And it went from a year ago not existing at Palantir to being deployed at every single deployment that we have at Palantir. And the interesting thing for me is about the process that we took to build this product and not necessarily the product itself. So I'm going to go a little bit in describing, what Palantir does, what the product is, and then kind of like the process that we took to build this. Cool, and the first thing I want to talk to you guys is about what Palantir does. I don't know how many of you know what Palantir is, but it was founded in 2004 by people coming out of PayPal. And one of the core things that they did at PayPal wasn't just build a scalable transaction system, it was how to do it without getting defrauded in the process. When they were a startup, they were losing a large amount of their revenue to the Russian mob. And so this was not a problem that they could just stop. And they did what any good startup did, was basically use something that already existed. They took automated systems to detect fraud and try to apply this to the problem. However, what they found was every single time they updated the algorithm, the Russian mafia was able to figure out a way around it. And I don't know how many of you have like a real experience in that, but it's something that we deal with all the time at Palantir. But what they did find is whenever they sent a person to figure out what was going wrong with the algorithm, the person did a really good job of figuring out what the mobsters were up to to get around the algorithm. Unfortunately, you can't just hire hundreds of people to look at transactions all day. That's way too expensive, especially for a startup to do. So instead, they did the next best thing. Build a system that allows computers to do what they're good at, triaging millions of transactions, and have humans do what they're good at, basically finding the novel fraud. And this is actually a pretty cool insight into the limits of computation and what people are actually really good at. And the system worked and allowed PayPal to succeed. And as many of you know, they were eventually bought out by eBay. So fast forward to the September 11th terrorist attacks. The problem wasn't that the US government didn't have the data to stop the attacks. The problem was a technology and policy issue. If only they could search the data. But even the PayPal people knew it wasn't going to be computers who were able to detect the bad guys. People would have to track them down. And thus Palantir was born with the mission of taking humans and computers working together to counter terrorism. And then fast forward a few years, just to a couple years ago, Palantir started expanding into areas beyond just the government. We've since expanded into many different commercial areas, starting out with things that were similar to what we did in government, such as cybersecurity or credit card fraud. But basically taking the same sort of approach with humans and computers working together. We've since expanded into wildly different areas, such as Medicare or even manufacturing. And every year we're expanding in more and more places. But how are we able to expand such different industries? And as it turns out, all these industries have a core problem that Palantir has been working on since the beginning. They all have tons of data sources that weren't set up to be analyzed. So for example, we have found mainframes from the 70s, or even banks that don't have unique identifiers for their customers. All things that we in the tech industry expect. And this example up here, this is actually a graph from one of our customers of what their data ontology looks like. And you're not expected to read it. Basically, at these places, we have to spend a lot of work modeling and refining for it to make sense. So step one, or step zero, is actually make the data make sense. How do you get the data into a place where it even makes sense to a computer, not even just a human yet? But then the issue is, at all these places, all these places, such as banks, don't have data experts. They're not technologists. So we have to write the data in their language. So ultimately, what we have to do is take this modeled ontology and turn it into something that looks a little more like this. Basically, a human readable interface, whether they're an analyst or some sort of petroleum engineer. So what allows us to really move quickly is we have a whole suite of products that we go to these different places. And with a small tweak, something that we built for petroleum engineering could work for Medicare, or something that we worked for credit fraud could work for Border Patrol. But every so often, we find that we're missing some piece of the puzzle, some sort of product. There's some sort of gap that we're missing. And that's where my team comes in, the forward deployed product development team. Whenever we're deployed, we frequently have a customer who has been trying to solve a problem for years. They have failed and are now in some sort of crisis. And the story of Contour starts on September 2014 with a United States Defense Department. And I'll give you guys a little background on what the internals of a defense department looks like. They have tons of data. They also have to turn around decisions very quickly and make sure that the decisions that they're making are correct. They also have tons of non-technical analysts. And what I mean by non-technical analyst is they're kind of like your parents. They don't know how to code. They don't know how to write SQL. And they're usually using the keyboard with only 1 or 2 fingers at a time, typing away. So basically, their problem can be boiled down to they have large amounts of data in their databases and analysts who don't know how to query them. So their workflow ends up looking something like this. The analysts figure out what questions they want to ask. For example, have any of our citizens been going to Syria? If they have been going to Syria, have they been talking to bad people? And then what they do is they write down that question, they send it to database administrators, and the database administrators run queries, which may take hours or days. And then once they get the results back, hand the results to the analyst that asked the question in the first place, so the analyst can begin starting their work. So obviously this workflow is pretty bad and can last up to days or weeks for an analyst to even answer such a simple question. But it does provide us a very interesting problem to solve. How do we build a large distributed system that non-technical users can query? And I don't know how many of you have dealt with large distributed systems or administrators or creators, but one of the scariest things for a creator is having users that aren't aware of the destructive powers of a Cartesian product on your system. But undeterred, 3 engineers, including myself, deployed with the analysts, and we started working on Contour. And within 3 months, we had a working solution that is basically described as a top-down analysis tool. And I'd like to show you guys what that looked like. If the video plays. Perfect. So this is what Contour looked like 3 months in. I checked out the source code and built it, and I loaded up a taxi data set that you've seen here now. There is geocoordinates and fare data. This is all open source real data that you can get from the New York State government of every single yellow cab in New York. And you can see here at Contour, we actually have a toolbar of widgets. There's the heat map visualizations. There's histograms, numerical distributions, all point and click, so analysts don't have to code or write SQL or anything. Something that you don't see in the video is we actually provide a ton of guardrails to make sure analysts don't accidentally bring back too much data. And even though none of our customers, as far as I'm aware, uses the taxi dataset, I find it's a very representative sample of what we like to do with it, with the data. For example, when you originally ask a question, you ultimately end up answering a whole bunch of different things that you didn't even know were important in the first place. So for example, the question I'm trying to solve here is, what's the worst time of day to go to the airport in New York City, since I end up flying so much? But as it turns out, I answered a whole bunch of different things along the way. For example, the data that you get from the New York City Transit Department is actually pretty dirty. There's tons of geocoordinates in the middle of the Atlantic Ocean claiming that someone got picked up there. Or even, did you know that the top grossing taxi driver makes $300,000 a year? Maybe I should consider switching your careers. And at the very end of the video here, we can see that we actually keep track of the different pieces involved in this analysis. And this is actually important for 2 reasons. One is, when you're making decisions in industry or in governments, it's very important to be able to track back what you did to arrive to your conclusion. The second is, we want to make sure that users aren't doing anything bad, and so we can always reverse engineer what they've done to help police the system to make sure they're not abusing what they have. So that was Contour. It is a top-down analysis product for large-scale data. That data set in there had 17 million rows, but we have it on data sets up to, I think, 150 billion is the largest. 150 billion rows is the largest data set that I've seen so far. And we have a very diverse set of users. We have analysts trying to find suspicious behavior. We have actuaries who are trying to figure out which policies are losing the most amount of money. We even have engineers at Palantir that use this tool to go explore data. And as we can see here from the chart, no good technical presentation is successful without a chart showing how you are up and to the right, both on data scale and interactivity. And we have sub-second queries across these 100 billion rows. And how we did that is we didn't do it through a large development team in Palo Alto or Silicon Valley. It was just 3 engineers embedded with the customer building this. And the backend, the distributed backend system, which I can talk about later, was written in Spark SQL, and the front end was Angular and TypeScript, if you're familiar with that. So how did we build all of this? How do we build the video in 3 months? Like, that's kind of crazy. Like, this is a huge engineering project. Well, as it turns out, we cut a lot of corners and we cheated a lot. What if I told you if you refresh the browser with this analysis and all your information would disappear? All the work would just like go poof and you're like left with nothing to start over again. Doesn't seem like a very good feature. But we did it anyway. And I'm going to tell you why like such a glaring like flaw in this web app was okay for this product. And I'm going to do that by explaining a different question. Like, so what is forward deployed product engineering? And hopefully I can explain to you why it's okay to have such a glaring problem with your product. So in most traditional business to business companies, you have 2 sides. You have product development and business development. In business development, you have your sales team, you have your sales engineers. They go out to the customer, deploy your product, and build whatever hacky solution they need to do to make sure your thing's actually working for the customer. Then you have product development. They have developers and product managers. They're the ones who take the hacky solutions from business development, throw them away, and build something architecturally sound. Forward deployed product development is, of course, both of these worlds combined into one. We basically have any one person on FDPD can be an engineer, a PM, or even a sales engineer. We make sure that everyone is able to do any of these roles, and frequently we all do them at the same time. And the reason for this actually makes us really good at building these products. It's actually core to the success. And kind of part of that goes back to a core principle of Palantir, is by putting engineers in the field, putting them next to the customers, unfiltered to the raw signal. Basically, we find that when you actually don't have any backup, engineers do all roles and are very successful, each of them. There's no MBAs telling you what the problem to solve. It's only you, and you have to figure it out. And this is actually very important for why we're successful. We find like there's so much nuance lost in human communications. There's so much context lost. Like, what problem are you actually solving? What's important? So much nuance and design that gets lost with a loss on a large team. And so even with 3 people, we can basically share everything, and everyone has the same mind state. And as much as I like to say how much we cheated on this, it is also very important to have very strong engineering prowess for this. We don't want to write anything twice. We want to make sure we're writing it once, and any decisions that we're making to cheat, we want to make sure we have the right trade-offs, which is why context is so important. So if it's so important to be able to write reusable products, it's so important to be able to write reusable products. So I want to talk to you about the next stage of the life cycle of Contour, going from doing like Defense Department analysis into something that's completely different. In this case, it was catching unauthorized traders at banks. So at these banks, they all have different sorts of in-house risk systems that they've built. And frequently, these risk systems are targeted towards their trading department to make sure that they don't find unauthorized traders. And what I mean by unauthorized traders are these are traders at banks that try to bypass systems that both the banks and the regulators have set up to prevent crazy sorts of losses, things like the subprime mortgage, from happening. And these guys are kind of like the stuff of nightmares for banks. As you can see from the timeline here, they like incur massive losses on the banks, large fines from regulators, and they even destabilize the economy. And despite what it looks like on here, it's not just a trader making a single bet at a single time. Usually they build up their positions over time. For example, they may be trying to hide losses that they've made, or they're just making riskier and riskier bets. Ultimately, unauthorized traders are gamblers. So why don't we catch unauthorized traders? How do they get away with what they're doing? Well, as it turns out, it's really, really hard to basically figure out when someone's doing something nefarious. Currently, what they try to do with their systems, with banks try to do with their systems, is they want to flag each individual trade as risky or not. They'll basically flag it as, is it outside of normal hours, or is it a canceled trade? And they basically try to build up these individual pieces of context and have managers try to look at this thing and figure out what's going on. So why is this so hard? Well, first of all is if you actually go back to each of those individual events where there was an unauthorized trader, you'll see that their behavior looks very similar to someone who's actually doing normal business. Just because you have a canceled trade or out of hours tradings doesn't necessarily mean you're doing something bad. Canceled trades happen all the time. Sometimes you have out of band trades if something important is happening in the world, like a financial crisis or if Tokyo decides to decrease their interest rates. The second is trading. Most of you probably haven't seen trading data, but it's incredibly complex. It's not just linear. You can make bets on trades on top of trades on top of trades. It's one of the most nonlinear data sets I've ever seen. There's a ton of it, and it's very hard to integrate. And the third is the people that they have in charge of figuring out if someone's doing something bad they're non-technical, they don't know code, and they don't know how to write SQL. And if that sounds familiar to you, we thought so as well. So we decided we're going to deploy Contour to help these guys try to catch unauthorized traders. So we embedded with the team at the bank who is in charge of writing these alerting systems to stop the unauthorized traders. We assumed that most of the usage would be from these non-technical people trying to catch unauthorized traders. But when we looked at the data, usage data for Contour, we actually found the technical people who were writing the alerting systems were also using Contour. So we talked to one of them, said, hey, you guys know SQL, you guys know how to write code. Why are you using this point and click tool to explore your data? And the reply we got was, it's so easy to use, even though I can write SQL to query all these databases, I'd much rather just use Contour to figure it out for me. And this was very surprising to us since we thought most of our usage would be from non-technical people, but it's also goes back to the insight of humans and computers working together. Even though these people are technical and they can do all this themselves, they'd much rather delegate the problem of writing these queries to Contour and just click a few buttons to get the answer. And this is why it's so important to embed with your customer to basically, this is an entire workflow that we would have missed. We would have focused completely just on the non-technical users had we not seen the technical users using it. And so Contour today, so this is what Contour is today in all the industries that we're in. So basically we went from 3 months in being at one customer to 10 different verticals within a year. So now it's kind of a core product at Palantir in less than a year. And this is not to say that all products at FDPD succeed or are successful. Frequently, we have many different products that don't even make it out of their first 3 months. But that's why it's so important to be able to iterate and test. If in 3 months we found that the analysts weren't using Contour, we would have thrown it away, and I wouldn't be here talking today. It would be a different product that we'd have found successful. So to wrap up kind of my talk about what's important for building these products very quickly, the first is find the right partner. And as evidence of the many different places that use Contour, there's so many different places that we could have possibly built this tool, since so many places need it. But what you really want to do is find the right partner who's willing to get dirty, willing to accept an unfinished product. For example, the data disappears if you refresh the page in order to start building with them. And the reason for that is you're looking for the 10x solution. You're not looking for the incremental solution. They're willing to basically do whatever it takes to solve their problem. If your partner is more concerned about moving the search box 2 pixels to the right, you should run as far away as you can. And the second is cheat, or ruthless prioritization. Basically, there's no feature that cannot go from your product. Basically, anyone can come up with a list of priorities. Any PM can go into a meeting room and say, hey, here's the list we need. But there's really no PM in the world who's going to be able to say, it's okay if your user's state doesn't survive. It takes people who are going to be able to cut anything in order to get the product out there and actually get usage for it. And the third is incredibly obvious. Have a good team. And what I mean by good team is basically you want FDPD engineers. You need people who can build systems. You need people who can prioritize themselves. And basically, they don't need a PM telling them what to do. And what you can actually do with the 3 awesome engineers is build Contour in 3 months. And do you remember the bug I keep talking about where if you refresh the page and everything went away? We ended up having to re-architect the entire front end. And it only took the 3 of us 2 weeks to do it. And that's what you can do with a great team. Cool. And that's it for my talk. Does anyone have any questions? So the question was, by embedding, were we literally sitting like with the companies that we were working with and coding? And yes, we were on site. That means I can't wear what I'm wearing now. I have to wear a button-down shirt and slacks. But yes. And that's incredibly important because you miss so much by doing it remotely. Even like frequently what will end up happening is they'll tell you one thing, like this is super important. You'll go there and realize that one thing that's super important to them doesn't actually matter and they want something else instead. And you can really only know that by going there. Yep.
How is it to work as embedded in other companies? How is to involve with people in these companies? Are you considered as colleagues or do you take coffee with him? Or?
Oh yeah, so the question is, how do the companies consider us? Yes. So frequently these larger companies have consultants that they've dealt with before. So we're frequently like seen as like, this other team, which is what we really tried to do is like show them that we're not just consultants. We're actually there to solve like their problem. And yes, we do get coffee with them. We want to make sure like, cause that's like the best way to understand like what they do and build a product that's going to scale for them. Yep.
So you mentioned that you found a lot of technical people are using your product. And I suppose as a technical user, you're able to drop down a level further down and see what's going on. How can you cater to being able to do your own queries while not confusing non-technical users?
So the question is, we had technical users and non-technical users using the product. How do we basically serve both of them? And the answer is we have a lot of flags. We have basically found there's kind of the dichotomy. You have non-technical users who get really confused and end up breaking things. And you have technical users who really want to do like more complex things with the data because they understand like what a left join is, for example. Non-technical people have no idea what a join is and you'll confuse them. So ultimately, we basically, because we have like such deep knowledge of the product or like kind of what Spark queries are going to be generated from this, we can say, okay, this is something a technical user wants. Is it going to blow up? How important is it? If it's going to blow up non-technical users, we'll create a flag for it, for example. And frequently, we've architected the backend such that it's really easy to throw up like a bunch of flags for the front end. So the front end, there was like a bunch of widgets that you saw. If we can actually like produce like a very complicated widget that allows like technical users to do like very technical things and just like not show that if there's non-technical users. Good question.
As you work for the military and many different sensitive information, was it hard to work with it, or did you have the clearance and everything?
Because there's a military involved, how hard is it to work with them? I would say it's much harder to work with like government or clearance things than it is for like private companies, for example, because there is like a security clearance process, whereas private companies are more willing to show you what their data looks like.
But if you don't have access to the data, how can you build a very powerful tool? That was my question.
Oh, yes. If you don't have access to the data, you basically have to, so because we couldn't see like the data particularly at some places, you really have to understand the users very well and like figure out how to like talk to the users to figure out what their workflows are if you can't see the data. Ultimately, it's way easier to build something when you can see the data. So I always like recommend going to places where you can see the data first and then going to places once you think you understand what a workflow is. And back.
My question is about the process of analyzing the data. It's manually for the users, this analysis with the entry of the user.
And so your question was, right now it's manually clicking around an interface. Is there a way to automatically kind of analyze it?
Yes, using the analyzing of the user to know what he's searching for the future.
Sorry.
Building new analytic tools based on what analytics people do.
Okay, building like new tools based on what people do. So right now we have like a few efforts to basically produce like machine learning things. We found that people are just so good at recognizing. So like a good workflow for, I think might answer your question would be, so we have a bank customer that we work for, and basically one of their people in their fraud department opened up Contour because there was a suspicious activity. They looked at it and like, oh wow, like someone's like obviously doing something very fraudulent because, you know, there's sub-second like transactions happening on this one POS terminal or point of sales terminal. And like, that's something that they can see like read like very quickly. And then what they do is build a rule automatically with a different product we have to catch that in the future. So this tool is like specifically for people to figure out what's happening in their data, and they can come up with like a hypothesis of what's happening. Oh, sub-second transactions on like any cash register is probably fraudulent. So let's make an automated rule now to catch that in the future. Are we using machine learning like in general, or we actually use a lot of machine learning for building models at places. So like this is like actually Contour helps out a lot with like figuring out what your data looks like, cleaning up your data before you start using machine learning. Like so in Contour specifically, we don't use machine learning, but we actually have tools to help build like linear regressions and like all sorts of things. But like you can't just go straight into machine learning. You have to understand really well what your data looks like first. Because otherwise you'll have no idea what's coming out of it. Yep.
Before you start working for Palantir, what were your background in data analysis topics?
Okay, what was my background? Cool. So I've been at Palantir for about 4.5 years. And before that, I was a software developer at a place called Endeca. You've probably never heard of it. It's in Boston, got bought out by Oracle. And basically I worked on there as like a column store and like search indexing. So if you're familiar with Elasticsearch, very similar to that, like proprietary product that eventually got bought by Oracle. And before that, I went to undergrad at Carnegie Mellon Computer Science prior to that. Yep.
Question about the data. When it's a mess, when you get in place, and as you mentioned earlier, sometimes there are different IDs for the exact same purpose or whatever.
Mhm.
How do you make sense of the mess?
Okay, so the question is, when we get the data, how do we make sense of the mess? And this is kind of like the core, this is like very, like something very core to like Palantir is we have a bunch of tools that basically help figure out like how to make sense of the data. And frequently, if the data is such a mess, you really need to talk to the people who use it. And because the people who use it are the ones who understand it the most. Because frequently like, you'll see like some sort of like ID. You're like, oh, this must be the ID. And then you'll talk to like a fraud analyst and they'll say, oh no, don't use that ID. It's always wrong. Use this one. And so part of the big thing we do is we say, how do we like encode this into like our system? And so we basically take that knowledge that they kind of have in their head and like build like a new system like moving forwards to say, cool, now our system knows that like this is the ID that you use to join. And so it's very different for different places. Sometimes we've seen the data source before, so we have automatic integrations for those. But frequently, if we're going to a place where they've written their own system back in the 70s, like you really have to have someone who knows what it looks like to figure it out. Usually not everything, because I mean, as you saw before, that like large graph of all the data sets, you want to start off with a piece that is going to get you like to solve whatever problem you're solving. Because if you want to like, you can't just go in and build a perfect world from scratch. It'll take you 3 years, and by the time the 3 years is over, the problems will have changed. So you really want to like find what's like the smallest piece that you can break off and solve quickly, and that'll tell you which pieces of data that you actually need to do that. Yep.
What is Contour's market position and competition? How you position in the States or in the world?
So the question is, how is Contour's market position? And we don't actually compete directly with, I guess, other products that do something similar. I think there's maybe a couple things, I forget their names though, that do something similar. I don't think there's anything I've seen that works at the scale that we're at. And we don't actually sell like Contour directly. We like work, Contour is like just a part of the solution. And so it's kind of like, hey, like here's one tool that we use like specifically for this. Like, so for example, like for credit card analysts for finding fraud, like this is a tool for them to explore their data. If there's something suspicious happening, like investigate it. There's like a bunch of other tools out there to like help with data integrations, running nightly pipelines, and also writing that automated alert from before. Yep.
Aren't you afraid that with a tool like Control, some companies will just forget to try to have clean data, clean databases because they ultimately will have a tool to sort all of this?
So the question is, are we afraid that customers won't clean up their data because they already have a tool to basically do the search? And so yes, if we make it really easy, no one will do the right thing. So which is why we kind of, one of the next like features that we're putting in Contour is how to write stuff back into like your data source from it. So ultimately, if you do something in Contour to say, oh, like I know these two things are the same value, it'll actually capture that and like write it back as well. But we have seen that like that's like part of like the evolution of paying attention to what your customers are doing. And if you make it really easy, they're going to want to do that. So we make it easy for them to do the right thing. Yep.
How do you deal with updates with Contour? Because it's a core product you made,
Mm-hmm.
and I think you are doing specific versions for your customers. How do you deal updates with core product at clients?
Yep. So the question is, how do we deal with updates whenever you do Contour? So this is probably something about Palantir that you'll never see at other like SaaS companies. SaaS is software as a service. Basically, you know, Google has Gmail. There's only ever one version of Gmail live. You know, there's only ever one version of Google unless they're A/B testing. So we actually have a lot of tooling internally designed specifically for deploying new versions of code or new versions of products. So we basically use Puppet. If you're familiar, it's like configuration management. So Contour comes in a bundle that's been puppetized. And so whenever you want a new thing, you just reach back to the main repository, you pick which version you want, and we'll deploy the new thing. And there's a bunch of scripts to test that the upgrade worked. And like that's something that's like fairly specific to Palantir, just because the way we operate is all these different places gets like their own piece of software. Good question. Yep.
How often do your customers come back to you because they miss one feature and they want more things, more tools to enhance their data?
I would say most of them that stick around, like that's like a very important feature of our customers is these places are so big and have so much data that once we do something really well, they figure out, oh wow, like these guys have a clean data set, they like know what they're doing, and like they actually give us tools. And so basically it's showing them that we can do something valuable and then basically do that over and over again. Cool. One more or a couple more questions, and then I'll introduce some people and you guys can come up to us and ask us them. Yep.
Do you have a real-time algorithm, or you work like for financial, or you use your software just when they ask you?
So the question is, do we have a real-time algorithm, or do we just use a software when they ask us? So I'll answer the second question first. So basically, we deploy the software to their users. So like they don't actually have to ask us to use the software at all. So like once we basically build a system. So for example, credit card fraud analysts I'll go back to. Like we already have the system installed, and like they can use it. They like are basically doing the searching, finding the bad things. And for the real-time stuff, we have a few real-time pieces that we're testing out right now. But like we don't do the like analysis ourselves. Like we're not doing like anything. But the real-time stuff is more about alerting than it is like financials. Right? Yep.
So I think Palantir was created like 12 years ago. I'm just wondering, I know there's a data part and a person part. Has the data to person ratio changed very much in 12 years? Or is it still the data just gets smarter and the people can do better searches? Or no, you can actually say you need half that amount of people you did before because
So the question is, there's a people part and there's a data part, which I guess is like a software data part. I mean, yes, that's how, I guess that's how we've succeeded is we basically go to these different places and start building products. Like specifically, it's like, cool, we built Contour because we knew we needed a tool that was, point and click for non-technical users. And so now we can use that everywhere. And it's like, okay, we're going to need real-time stuff. So we're prototyping some real-time things. And the goal is to say, hey, you have a real-time problem, here's like the product we built for that. And it's kind of like collecting the different pieces of products that work together over time. Let me introduce a few people. So this is my two colleagues, Emmanuel Firm and Caroline Henry. Caroline speaks French way better than I do, which is I don't speak at all. So if anything was confusing, you should talk to her. And I guess like I'll put down the microphone now and you can come up to us and talk to us if you have any more questions. And thank you for coming out.